This is far more detailed than you'd want to. In fact, I would probably fall asleep right now if I read all this. But remember, just factoring. If you first going to want to look for factoring a greatest common factor first. Always look for that first, no matter how many terms there are. If there are two terms, then yeah, maybe some are difference of, well, I guess some are different of cubes or the difference of two squares kind of stuff. It won't always work out that way, I suppose. It actually should right now until we get a little bit more experience. But if there's three terms, you can look at factoring a perfect square trinomial. But again, factoring by grouping is always good. And then if there's four more terms, really just four is what we should be looking at. Factoring by grouping is, it's pretty convenient. Now we may see one of those examples where it's just gonna have two terms, but it actually ends up being a factoring by grouping because it's already grouped for us, which is convenient. I guess that'd be a greatest common factor one. Always factor completely. So if you don't, even if you factor the greatest common factor in the beginning, always look in the end and see if one of your two binomials can be, you can factor something out from there as well. So, and then write the complete factorization by checking. Also, you can check by going back and multiplying everything back together just to make sure you get the original expression. So, and you can pretend to have fun while you're doing it. Is there a way we can do it like a set algorithm every time? Not necessarily. I mean, the greatest common factor is, but after that, it's just kind of taking your time, like this one right here. Take your time, look at it, think about it. What are you gonna do for this one? And this is one of those greatest common factor ones. So we got this x minus 2 in both, there's only two terms here. And so I'm gonna pull out of that, these two terms an x minus 2 factor, and then what was left over? Well, we had the 9x and the plus 3. Now it's like, wow, that was victory right there, right? But remember, always look for some kind of greatest common factor, right? And you could have done this in the beginning, which we kind of did with the x minus 2, but now within this binomial, not this one, this binomial doesn't have any common factors you can factor out except for one, of course. This binomial, though, has a factor we can factor out. From there, I will factor out a 3 because the 9 and 3 are both divisible by 3. All right, fair enough. Then what are we left with? Well, 9 divided by 3 is 3, so that's how many x's there are. 3 divided by 3 is 1, so we get 3x plus 1, and then I still have that x minus 2 binomial as well. So we end up with 3 factors in our final expression, but
I know how to